Hello and welcome to part 2 of the introduction to differentiation. In this video, we're going to go over the product rule, quotient rule, and the chain rule, how to apply it, and we're going to solve some examples together. But before that, I just want to quickly show you something that is called the sum rule of differentiation, which is something that we all do, but we don't know that it's called the sum rule. Basically, if I have y equals 3x squared plus 4x plus 1. If I want to get dy by dx, which is basically the derivative of y or the differentiation of this function, is going to equal each term differentiated alone. And we know that from the power rule, x power n, so dy by dx, this is y, the differentiation is going to be power times coefficient, so n times 1 is n, x to the power of n minus 1. So this is basically the power rule. So for the sum rule, we do this power rule for each term separately. So for the 3x squared, 2 times 3 is 6, x power 2 minus 1 is 1, plus 4x, so 1 times 4 is 4, and then x power 0, because 1 minus 1 is 0, which is basically 4, and then we know that the differentiation of a constant is 0, so this is dy by dx. Another example for the sum rule would be if y equals 5x cubed minus 2x, then dy by dx is going to equal each term differentiated alone, so it's going to equal 15x squared. 3 times 5 is 15, 3 minus 1 is 2, and minus a 2. Basically, this is the sum rule, and we're going to be using it from now on for probably every differentiation question that we get. So first, let's start the video by introducing what is the product rule. Product rule tells me that when I have two functions, let's say y equals the first function f of x multiplying another function named g of x. When I want to get the differentiation of this, so basically dy by dx, what I'm going to do is, let me just put this here. So basically dy by dx is going to equal the first function differentiated, so f dash of x is basically the derivative of f of x, multiplying the second function normally without any differentiation, and then adding to it the opposite, the first function normally times the derivative of the second function. This is the basic rule. However, I don't like to go through rules. I don't like to waste time on rules. It's better to jump into examples to see how this works. So let's say we have y equals 3x plus 4 times 2x minus 3. So if I want to get dy by dx of this function, I know from this rule that it's the derivative of the first one multiplying the second one. So what's the derivative of the first one? It's basically derivative of 3x is 3 and derivative of 4 is 0, multiplying g of x, which is 2x minus 3, adding to it f of x, which is 3x plus 4, multiplying g dash of x, which is the differentiation of this function, which is going to be basically 2. Then simplifying, we're going to have 3 times 2x is 6x, 3 times negative 3 is negative 9, plus 2 times 3x is 6x, 2 times 4 is 8. So we're going to have an answer of 6x plus 6x, which is 12x, and then negative 9 plus 8, which is minus 1. So this is the answer. Let's take a look at another example. Let's say if we have a function y equals 1 over x times 4x plus 5. Again, the rule tells me it's the differentiation of the first times the second function, adding to it the first function times the differentiation of the second function. So here my f of x is basically 1 over x, and my g of x is 4x plus 5. So let's do that. So what's the differentiation if f of x equals 1 over x? Okay, I can rewrite it as x power negative 1. And the differentiation of that is going to be the power rule. So negative 1 times 1 is negative 1, x, and then negative 1 minus 1 is negative 2. So this is the differentiation. So let's continue with the product rule. So the differentiation of the first one is going to be negative x power negative 2 multiplying g of x, which is 4x plus 5, adding to that f of x, which is 1 over x, times g dash of x, which is a differentiation of 4x plus 5, which is basically 4. This is dy by dx. So let's simplify. So negative x squared times 4x is basically negative 4. X minus 2 times x is basically, we add the powers, so negative 2 plus 1 is negative 1. And then negative x power negative 2 times 5 is negative 5x power negative 2. And then we add to that 4 over x. We know that 4, this could be written as negative 4 over x minus 5x power negative 2 plus 4 over x. We know that this is negative, this is positive, they can cancel with each other, and then our answer is going to be negative 5x power negative 2, or I can rewrite it as negative 5 over x squared. So we can take another example where y equals square root of x times 4x plus 5, and I can rewrite this as x power half, because square root of x is the same as x power half multiplying 4x plus 5. Let's do our product rule. So dy by dx is going to equal differentiation of the first, so differentiation of x power half is basically half x, and then the power minus 1, which is half minus 1, and I know that half minus 1 is basically negative 1 over 2. Then I multiply that to g of x, which is 4x plus 5, and then I add f of x, which is x power half, multiply g dash of x, which is basically 4. So this, when I simplify, half times 4 is 2, x power negative half times x, so negative half plus 1 is basically half, or 1 over 2, plus half x power negative half times 5 is basically 5 over 2 x power negative half, and then we have a 4x power half. So we can simplify here. We know that 2 plus 4 is 6, so this is going to give me 6 x power half, or 6 root x, plus 5 over 2, and then this x power negative half can go down as x power half, or x under the square root. If I would like to combine this to a single fraction, I will need them both to have the same denominator. In order to have this, the denominator of 2 root x, I will need to multiply down by 2 root x and up by 2 root x. So this is going to give me an answer of 2 times 6 is 12, root x times root x is x, then plus 5 over 2 root x, and then I can add to it 5 over 2 root x. Now I can do my summing, so it's going to equal to 12x. Okay, this is only 2 root x times 6x. This is the 5. So when I add them, it's 12x plus 5 over 2 root x. We can move on to another example, which is y equals 2x squared times 4x plus 5, and I want dy by dx. So again, dy by dx is going to be differentiation of f of x, which is going to be 4x, times g of x, which is 4x plus 5, and then adding to that f of x, which is 2x squared, times the differentiation of g of x, or g dash of x, which is going to be 4, because the differentiation of 4x is basically 4. So 4 times 4 is 16, x times x is x squared, 4x times 5 is basically 20x, and then I will add to that 2 times 4 is 8, so 8x squared. 16 plus 8 is basically 24x squared plus 20x. So I hope this is clear for the product rule, and now we can move on to the next rule, which is called the quotient rule. And from its name, the quotient rule is a rule when we have two functions that are dividing each other. Just like when we have the product rule from its name, where we have two functions multiplying each other, like f of x multiplying g of x. So let's take a look on how to work with the quotient rule. So basically, the quotient rule says if I have a function where y equals two functions dividing each other, so f of x divided g of x, then dy by dx is going to equal the first function differentiated, or the derivative of the first function, multiplying the second function normally without any differentiation. And then now I will subtract from that the first function normally multiplying the differentiation or the derivative of the second function, and all of that I will divide by the second function without any differentiation to the power of 2 or squared. So let's see how we can go through that. Let's take our first example, which is y equals x plus 1 over 2x plus 1. So this top function is my f of x. This denominator function, or the function denominator, is g of x. So this is f of x. This is g of x. So let's apply our rule. So our rule says that this is a differentiation of the first function, and the differentiation of x plus 1 is basically 1. And then I multiply the second function, which is 2x plus 1. Then I subtract the first function, which is x plus 1, multiplying the derivative of the second function, which is the derivative of 2x plus 1, and that is 2. And all of that is dividing g of x, which is 2x plus 1 squared. So doing some simplifications, I know that this is going to be 2x plus 1 minus 2 times x is 2x, and then minus 2 times 1 is negative 2 over 2x plus 1 squared. So 2x and 2x will cancel. 1 minus 2 is going to equal a minus 1 over 2x plus 1 squared. This is how you apply the quotient rule. We can take a look at another example for the quotient rule. Let's say we have y equals x squared over root x. Let's apply our rule. So our rule says that it's the first function, so dy by dx, or the derivative, is going to equal the first function differentiated, or the derivative of the first function, or the function on the top, which is going to be differentiation of x squared, which is 2x, multiply root x, and I will write it as x power half for now. And then I will subtract the first function, which is x squared, times the differentiation of the second function, which is x power half. And I know that the differentiation of x power half is equal to half x and then half minus 1, which is negative 1 over 2. So it's basically going to be half x power negative 1 over 2. And all of that is divided by g of x to the power of 2. So simplifying, 2x times x power half. So I will add the powers. This is a power of 1, this is a power of half. So it's going to give me a 2x power 1 plus half is 3 over 2. Minus, I have a 1 over 2 here. Then I have x, which 2 minus half is also 1.5, or 3 over 2. And then I will have square root of x squared. This is going to give me an x because the square and the square root are going to cancel. And then I can simplify here. I have a 2 minus half, which is basically 3 over 2, x power 3 over 2, because these are common terms, because the x have the same power, so I can subtract the half from the 2 over x. So this is basically x power 3 over 2 dividing x, which is the opposite of when you multiply. When you multiply, you add the powers. When you divide, you subtract the powers. So we have a 3 over 2 minus 1, or 1.5 minus 1, which is basically half. So these two I can rewrite as 3 over 2 times root of x, or x to the power of half, which is the same as root of x. Right. Let's take another example. Let's say y equals x squared plus 1 over x squared minus 1. Again, let's do the same thing. So our dy by dx is going to equal the first function, or the derivative of the numerator function, which is derivative of x squared plus 1, that is 2x, multiplying g of x, which is x squared minus 1, and then subtracting the first function, multiplying the derivative of the second function, which is x squared minus 1, which is also 2x, and over g of x, which is x squared minus 1, all to the power of 2. So let's simplify. 2x times x squared is basically 2x cubed, and then 2x times negative 1 is minus 2x, and then I have a minus 2x times x squared, which is minus 2x cubed, and then I have a minus 2x times 1, which is minus 2x. All of that over x squared minus 1, all to the power of 2. I have a 2x cubed, which is going to go with a 2x cubed. Minus 2x is basically minus 4x over x squared minus 1, all to the power of 2. And this is the final answer for this question. Right, let's take one more example. Let's say if we have y equals 4 over 4 minus x squared. Let's say I want to have dy by dx. Again, we're going to do the same thing. So it's going to be the differentiation of the numerator. Differentiation of constant is basically 0, multiplying, because the constant here is 4, differentiation of any constant number is 0. 0 multiplying g of x, which is 4 minus x squared, and then subtracting f of x, which is 4, times the differentiation of g of x, which is negative 2x, all over 4 minus x squared to the power of 2. So this part, anything times 0 is 0, and I will have a negative 4 times negative 2x, which is a positive 8x over 4 minus x squared power 2. So this is basically how to go on and solve the quotient rule. Right. Let's try and move on for the next concept, which is the chain rule of differentiation. So we took the product, which is basically two functions multiplying each other. We took the quotient rule, which is basically two functions dividing each other. Now we will take a look at the chain rule, which is a function inside another function. So let's say we have a y equals f of g of x. So basically we have this g of x, which is a function. It's inside another bigger function, which is f of x. And let's see what is dy by dx going to be for that function. So my chain rule tells me that the differentiation of something like this is going to equal the differentiation of the first function, the outer function, with g of x inside it, and multiplying the differentiation of what's inside, or multiplying what is inside. Okay, so let's say how we can apply this through examples. So let's take the first example where y equals 3x plus 4 to the power of 3. So this is a function inside another function. I want you to think as the power 3 is the bigger function, which is f of x, or f of something, and inside that, instead of x, instead of just x power 3, so it's just f of x, no. We have another function inside it, which is g of x, which is 3x plus 4. So applying this is basically you deal with this function as just normal x for now, and you differentiate it as normally, as normal power rule. So dy by dx is going to equal, we know that the power rule is power times coefficient, so 3, and the coefficient here is 1, so 3 times 1 is 3, and then we know that we reduce the power by 1. So normally, as if we had an x cubed, what we would do the same thing, 3x squared, but instead of x, we have g of x, okay? The extra thing that we need to do here is that we need to multiply by the derivative of this g of x. So what's the derivative of 3x plus 4? It's basically 3. So my answer is going to be 3 times 3, which is 9 times 3x plus 4 all to the power of 2. Let's try and take another example. Let's say we have a question where y equals 2x plus 3 power 7, and I need dy by dx. So I know that this 2x plus 3 is inside the bigger function, which is to the power of 7. So in order to go through that, I will do my chain rule. So it's 7 times 2x plus 3, reduce the power by 1, which is 6. And I'm not done here. I will need to multiply by the derivative of what's inside. So the differentiation of what's inside is basically differentiation of g of x, or differentiation of 2x plus 3, which is basically 2. This is going to give me 2 times 7, which is 14 times 2x plus 3. Let's take another example. Let's say we have y equals square root of root x plus 1. So rewriting this is basically a big bracket to the power of half, which is this big square root. Okay, and inside that I have another square root, which is x power half plus 1. So if I want dy by dx, what I will do is I will multiply the power by the coefficient, which is also 1. So half times 1 is half. Then I will rewrite my exact function inside, not changing anything. And then I will subtract the power by 1. 1 half minus 1 is basically negative 1 over 2. And then I'm not done. I need to multiply by what's inside. So the differentiation of what is inside of this is basically the differentiation of x power half plus 1. We know that the differentiation of plus 1 is 0. So the differentiation of x power half is basically half x and then reduce the power by 1. So half minus 1 is negative half. So let's see. So we have a half times half. This is a 1 over 4. And then this whole thing is to the power of negative half. So we can bring it down as x power half plus 1 power half, because when we flip this, bring it to the denominator, the power goes from negative to positive. And then this is multiplied by x power negative half, or I can do the same thing. I can bring it down, so basically multiplying by 1 over x power half. This is equal to 1 times 1 is 1 in the denominator, and I have a 4 times square root, because this big thing I can change it for a square root of x plus 1, and then I have multiplying by x power half, or root x. So this is basically my answer for this question. Right. Let's take another example, which is y equals 3x squared plus 3x minus 6 all to the power of negative 8. Again, I will use my chain rule. So it's going to be negative 8 times 1 is basically negative 8 times, and I write the same exact function, not changing anything. I just reduce the power by 1. So negative 8 minus 1 is negative 9. And then I multiply by the differentiation of what is inside. So the differentiation of g of x, or what is inside, is basically 2 times 3 is 6, x, 2 minus 1 is 1, and then plus 3x, the differentiation of that's 3, and then differentiation of negative 6 is basically 0. So what I can do from here is I can multiply this negative 8 into this bracket over here. So I'm going to have 8 times 6 is basically negative 48x, and then minus 8 times 3 is basically 24. And then I will put this whole thing in the denominator because it has a negative power. So it's going to be 3x squared plus 3x minus 6 all to the power of positive 9. And this is going to be my answer. And last question for today, we can take y equals the fifth root of 7x minus 8. And I can rewrite this as 7x minus 8 to the power of 1 over 5. Let's use our chain rule to get dy, or the differentiation, dy by dx, is going to equal 1 over 5 times the coefficient, which is 1, is basically 1 over 5. And then I would write my exact same function inside. This is a minus. And then I will reduce the power by 1. So 1 over 5 minus 1. 1 over 5 minus 1 is basically the same as 1 over 5 minus 5 over 5. So it's basically equal to 1 minus 5 is negative 4. And then I copy the denominator. So it's negative 4 over 5. And then I multiply by the differentiation of what's inside. The differentiation of 7x minus 8 is basically 7. So I can multiply the 7 over here. So it's going to be 7 over 5. And instead of this negative power, I can put it in the denominator to have a positive power. So it's going to be 7x minus 8 power positive 4 over 5. And this is going to be my answer. I hope this lesson was beneficial. I hope that you feel free to like, comment, and subscribe. Please suggest what topics and what questions you have in the comments down below, and I will go through them. And till the next video, thank you for watching. Don't forget to subscribe. Have a good day.